Hey there, chemistry students. In this video, we're actually going to talk about converting between all three of the units that we had previously discussed. So we're going to talk about converting between mass, moles, and the number of representative particles. Let's jump right into a couple of sample problems. Here's our first sample problem. How many atoms are in 18.5 grams of sodium? Well, the first thing that I'm going to want to do is to write down both conversion factors that I know of. So for sodium, we know that 1 mole of sodium is equal to 22.990 grams. That's the molar mass of sodium. We find that number on the periodic table. The other thing that I do know too is that 1 mole equals 6.022 times 10 to the 23rd representative particles for sodium. Now, the smallest piece of sodium is called an atom. So for this problem, it would be 6.022 times 10 to the 23rd atoms. Well, now we can actually get started. So I know that I'm going to be converting, so let's get some conversion field goalposts ready. And I know that I'm going to take my given and I'm going to put it over 1. Well, where am I going to convert to, though? I know I'm going to start off with my 18.5 grams, but I think in this problem, we're actually going to end up converting over to atoms. So I'd love to be able to go directly from grams to atoms, but if I look through my conversion factors, I have grams to moles, and I have moles to atoms, but I don't have anything directly from grams to atoms. So I think grams to atoms isn't really going to work directly for this, but we might be able to do this in 2 conversion steps. So let's link both of these steps together. So I know that I can go from grams to moles, and I know that I can go from moles to atoms. So let's just take 2 steps to get to where I need to go. I know that grams needs to cross down to the bottom of the next box in order to cancel out. So I'm going to look at the 2 conversion factors that I have above and find the one that has grams in it. So I'm going to drag the grams down to the bottom, and the other half of the equals statement, the equivalent statement, is going to go to the top of the fraction. Almost there. I know I'm not done because what's in the top of my last box isn't atoms yet. I need to keep going. So I know that moles needs to cross down to the bottom of my next box. And I know I need another conversion factor. Now remember, we just used up 1 mole equals 22.990 grams. So I'm really only left with one choice. 1 mole equals 6.022 times 10 to the 23rd atoms. So let's fill in that information. The 1 mole goes to the bottom, 6.022 times 10 to the 23rd goes to the top. And what do you know? In the top last box, I have now atoms. And that's exactly what the problem was asking me for. So now I'm all left to plug and chug. Plug it into the calculator, chug back out an answer. And in this case, I find that my answer is 4.85 times 10 to the 23rd moles of sodium. Now notice here, I should say atoms of sodium, I do apologize. So again, 4.855 times 10 to the 23rd atoms of sodium should be my final answer. Let's take a look at another sample problem. In this case, we're also going to go the reverse direction. How many grams are in 6.9 times 10 to the 24th atoms of sodium? Same process. The first thing you're going to want to start with is your conversion factors, and we do know 2. The first one that we know is that 1 mole equals 22.990 grams for sodium. That's the molar mass of sodium, the numbers found on the periodic table. The second thing that we do know is that 1 mole equals 6.022 times 10 to the 23rd atoms. Again, the smallest piece of sodium in this case is called an atom. An atom would be its representative particle. So we do know that we're going to do some conversions. Let's get started with our setup. Our given is 6.9 times 10 to the 24th atoms. That's going to slip into our problem over 1. And we know in this case we want to convert to grams. Well, that would be lovely. I'd love to go directly from atoms to grams. But unfortunately, I don't think I have any direct conversion factors. I have grams to moles, I have atoms to moles, but I do not have atoms to grams. So we're going to start off with atoms, then go to moles, and then we're going to go from moles to grams. 2 steps. Let's get started. So we know that we're starting with the 6.9 times 10 to the 24th atoms of sodium over 1. We know that atoms has to cross down to the bottom of the next box to cancel out. There's only one conversion factor that has atoms in it, so we just need to fill in the information. The 6.022 times 10 to the 23rd sticks with the atoms, and the 1 mole must go to the top. And we're not done yet. The problem asked for grams. We're not there yet, so we have to keep going. In the top of the last box, we know that we're left with moles. Moles is going to need to cross down to the bottom of the next box to cancel out. And I need another conversion factor. Now I know I've already used up 1 mole is 6.022 times 10 to the 23rd atoms, so probably time to use the last conversion factor that we have. So let's fill in the information in the correct spots. Moles have already filled into the bottom, so we just need to fill in the number with it, 1 mole, and the 22.990 grams of sodium goes to the top. Since we have grams in the top last box, now it's time to solve. So let's plug and chug into the calculator, and what we find is that we're going to have about 270 grams of sodium. Now notice 6.9 times 10 to the 24th only has 2 significant digits. Only the number in front of the scientific notation counts. So 6.9 has 2 sig figs, so we're going to keep 2 sig figs in our final answer, 270 with no decimal point. One more problem just to make sure that you've got it. How many grams are in 6.9 times 10 to the 24th molecules of water? So now this time, instead of dealing with an element, we're dealing with a whole molecule. Let's go through the same process that we did before. Again, the first thing you're going to want to do is to write down the 2 equivalence statements, the 2 conversion factors that we know that goes between moles, atoms, and grams. We know that 1 mole of water is going to equal 18.015 grams. That's the molar mass. Again, you would add up the mass of 2 hydrogens and 1 oxygen to get the total molar mass. The second conversion factor that we know is that 1 mole equals 6.022 times 10 to the 23rd molecules. And again, that's the representative particle, the smallest particle of water that you can still call water, H2O. It's called a molecule. So now we're ready to get started. We know that we're given 6.9 times 10 to the 24th molecules and that we need to get to grams. So again, there's no direct conversion. In this case, we're going to need to go from molecules to moles first, and then from moles to grams. So let's get started with our conversion. We're going to take our given 6.9 times 10 to the 24th molecules and pop that over 1. Molecules crosses down to the bottom of the next box. Let's find a conversion factor to fill in some numbers. The bottom one looks pretty good. 6.022 times 10 to the 23rd molecules will go to the bottom, and 1 mole goes to the top. Now, once again, that means that we've used up this conversion factor. We also know that we're not finished. The problem asks for grams, and in the top last box, we're still left with moles. We have to keep going. So we know that moles needs to cross down to the bottom of the next box to cancel out. Again, we've used up the last conversion factor. 1 mole equals 6.022 times 10 to the 23rd molecules, so we're not going to use it again. So let's figure out how this last conversion factor plugs and chugs in. Match the units. Moles is on the bottom, just fill in the number, and then the other half of the equivalent statement will go to the top, 18.015 grams of water. Now, since we have grams in the top last box, it's time to plug and chug. Plug it into the calculator, chug back out an answer, and this time you should find that your final answer will be about 210 grams of water. Again, two significant figures go in 6.9 times 10 to the 24th. Only the number in front of the times 10 to the counts. So we'll have two significant digits on the way out.